mechanism. Protocol upgrade mechanism. The HTTP 1.1 protocol provides a special mechanism that can be used to upgrade an already established connection to a different protocol using the upgrade header field. This mechanism is optional. It cannot be used to insist on a protocol change. Implementations can choose not to take advantage of an upgrade, even if they support the new protocol. And in practice, this mechanism is used mostly to bootstrap a WebSocket connection. Note also that HTTP2 explicitly disallows the use of this mechanism. It is specific to HTTP 1.1. Upgrading HTTP 1.1 connections. The upgrade header field is used by clients to invite the server to switch to one of the listed protocols in descending preference order, because upgrade is a hop-by-hop header. It also needs to be listed in the connection header field. This means that a typical request that includes upgrade would look something like. Other headers may require depending on the requested protocol. For example, WebSocket upgrades allow additional headers to configure details about the WebSocket connection, as well as to offer a degree of security in opening the connection. See upgrading to a WebSocket connection for more details. When the server decides to upgrade the connection, it sends back a 101 switching protocol's response status with an upgrade header that specifies the protocols being switched to. If it doesn't or can't upgrade the connection, it ignores the upgrade header and sends back a regular response, for example, a 200K. Right after sending the 101 status code, the server can begin speaking the new protocol, performing any additional protocol-specific handshakes as necessary. Effectively, the connection becomes a two-way pipe as soon as the upgraded response is complete, and the request that initiated the upgrade can be completed over the new protocol. Common uses for this mechanism. Here we look at the most common use cases for the upgrade header. Upgrading to a WebSocket connection. By far, the most common use case for upgrading an HTTP connection is to use WebSockets, which are always implemented by upgrading an HTTP or HTTPS connection. Keep in mind that if you are opening a new connection using the WebSocket API or any library that does support WebSockets, most or all of this is done for you. For example, opening a WebSocket connection is a single method. The WebSocket constructor does all the work of creating an initial HTTP 1.1 connection, then handling the handshaking and upgrade process for you. Note, you can also use WSS URL scheme to open a secure WebSocket connection. If you need to create a WebSocket connection from scratch, you will have to handle the handshaking process yourself. After creating the initial HTTP 1.1 session, you need to request an upgrade by adding the standard request the upgrade and connection headers as follows. WebSocket-specific headers. The following headers are involved in a WebSocket upgrade process. Other than the upgrade and connection headers, the rest are generally optional and handled for you or handled for you by the browser and the server when they are talking to each other. SEC WebSocket extensions specifies one or more protocol level WebSocket extensions to ask the server to use. Using more than one SEC WebSocket extension header in a request is permitted. The result is the same as if you included all of the listed extensions in one such header. Extensions. A separated list of extensions to request or agree to support. This should be selected from the IANA WebSocket extension and registry. Extensions which take a parameter do so by using semicolon delineation. For example, the header indicates two custom extensions, super speed and color mode, which additionally has a parameter depth equals 16. SEC WebSocket key provides information to the server which is needed in order to confirm that the client is entitled to request an upgrade to WebSocket. That header can be used when insecure clients wish to upgrade in order to offer some degree of protection against abuse. The value of this key is computed using an algorithm defined in the WebSocket specification, so this does not provide security. Instead, it helps to prevent non-WebSocket clients from inadvertently or through misuse requesting a WebSocket connection. In a sense, then this key confirms that yes, I really mean to open a WebSocket connection. This header is automatically added by clients that choose to use it. It cannot be added using the fetch or XML HTTP request header methods. Key. The key for this request to upgrade. The client adds this if it wishes to do so, and the server will include in the response a key of its own, which the client will validate before delivering the upgrade response to you. The server's response SEC WebSocket accept header will have a value computed based upon the specified key. SEC WebSocket protocol. The SEC WebSocket protocol header specifies one or more WebSocket protocols that you wish to use in order of preference. The first one that is supported by the server will be selected and returned by the server in a SEC WebSocket protocol header including the response. You can use this more than once in the header as well. The result is the same as if you used a comma delineated list of subprotocol identifiers in a single header. Subprotocol. A comma-separated list of subprotocol names in the order of preference. The subprotocols may be selected from the INA WebSocket subprotocol name registry, or may be a custom name jointly understood by the client and the server. SEC WebSocket version specifies the WebSocket protocol version and the client wishes to use, so the server can confirm whether or not that version is supported on its end. The WebSocket protocol version the client wishes to use when communicating with the server. This number should be the most recent version possible listed in the INA version WebSocket version number registry. The most recent final version of the WebSocket protocol is version 13. Response header. If the server can't communicate using the specified version of the WebSocket protocol, it will respond with an error, such as 426 upgrade required. That includes in its headers a SEC WebSocket version header with a comma-separated list of the supported protocol versions. If the server does support the requested protocol version, no SEC WebSocket version header is included in the response. Supported versions. A comma delineated list of the WebSocket protocol versions supported by the server. Response only header. The response from the server may include this: SEC WebSocket accept included in the response message from the server during the opening handshake process. When the server is willing to initiate a WebSocket connection, it will appear no more than once in the response headers. Hash. If a SEC WebSocket key header was provided, the value of this header is computed by taking the value of the key, concatenating the string to it. Taking the SHA-1 hash of that concatenated string results in a 20-byte value. That value is then base 64 encoded to obtain the value of this property.